Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0990 indicates a high circuit fault associated with the transmission fluid pressure switch E, specifically for the 6th clutch. When this fault is detected, the powertrain control module, PCM, enforces a fail-safe mode, restricting the transmission from shifting into any gear other than 3rd or 6th. This mechanism is crucial for preventing potential damage to the vehicle's transmission system. The transmission fluid pressure switch is responsible for monitoring the hydraulic pressure within the transmission. It is typically located within the transmission assembly and plays a vital role in enabling smooth shifting conditions. Understanding this code is essential for diagnosing transmission-related issues accurately and effectively, ensuring that any underlying problems are addressed to maintain optimal vehicle performance. The transmission fluid pressure switch E is a key component in the transmission system of the Honda Pilot. This switch specifically monitors the pressure of the fluid related to the 6th clutch, helping the system determine when to shift gears. It plays a central role in the vehicle's shifting mechanism by sending pressure data to the powertrain control module, PCM. The PCM relies on this information to make informed decisions about gear engagement and performance. The switch is generally housed within the transmission assembly, meaning that accessing it may require significant disassembly depending on the vehicle's design. If there are issues detected with this switch, the vehicle may limit its operations to prevent further damage, making it crucial to address any faults indicated by DTC P0990 promptly. Several factors can result in the triggering of DTC P0990. The most common cause is a faulty transmission fluid pressure switch, which may fail to provide accurate readings, leading the PCM to determine there is a fault in the system. Additionally, wiring issues such as frayed or broken wires can cause the signals to be misread or not transmitted at all. Poor connections or loose terminals between the transmission fluid pressure switch E and the PCM may also result in intermittent signals, causing the system to register this high circuit fault. Understanding these potential causes is critical to effectively troubleshoot the issue and ensure a proper resolution. A systematic approach that checks these components and their connections is essential during the diagnostic process. When DTC P0990 is present, drivers may notice several distinct symptoms affecting vehicle performance. The most prominent symptom is that the transmission becomes stuck in 3rd gear, preventing any higher gear engagement. Due to this fail-safe mechanism, the vehicle will not shift to the 6th gear, which can significantly affect driving dynamics and efficiency. Another common symptom is the illumination of the check engine light on the dashboard, signaling to the driver that there is a concern that requires attention. These symptoms are important indicators that, when observed, should prompt immediate diagnostic evaluation to determine the underlying cause. Addressing these symptoms proactively can mitigate more serious transmission-related issues in the future. The first step in troubleshooting DTC P0990 involves verifying the problem condition. Start by turning the vehicle to the on mode, followed by clearing the diagnostic trouble code using the HDS, which stands for Honda Diagnostic System. This essential step resets the system and prepares it for observation. Once cleared, securely raise the vehicle to ensure that all 4 wheels can rotate freely, and start the engine while disabling the Vehicle Stability Assist (VSA) by pressing the VSA off button. This may be critical if the vehicle is moving at speeds exceeding 31 miles per hour, 50 kilometers per hour, as it enters maintenance mode. After disabling the VSA, run the vehicle in 6th gear and use the HDS to check the parameters, specifically the 6th pressure switch status, to see if the conditions match expected thresholds. If the current conditions align with the thresholds, an intermittent failure without any additional issues is likely present, suggesting further checks on connections may be needed. If they do not match, the failure is confirmed, and additional troubleshooting steps are warranted. In the second troubleshooting step for DTC P0990, you need to identify potential failure areas related to the transmission fluid pressure switch E, along with other components. Begin by turning the vehicle to the off lock mode before proceeding. Then, disconnect the connector associated with the transmission fluid pressure switch E, 6th clutch, to isolate the circuit. Next, connect terminals A and B using a jumper wire to establish a direct connection that simulates normal operation. Terminal A corresponds to the switch's first pin, while terminal B connects to the vehicle's body ground. This connection helps isolate if the switch itself is malfunctioning. After setting up the jumper, turn the vehicle back to the on mode, and again, monitor the parameters through the HDS. If the current conditions reflect that the 6th pressure switch is on and matches the threshold, this would indicate that the switch is faulty and should be replaced. If the readings are not as expected, further investigation into the wiring or other potential faults should be conducted. The third troubleshooting step for DTC P0990 focuses on checking the integrity of the OP6SW line within the circuit. After verifying the previous steps, turn the vehicle to the off lock mode and remove the jumper wire to return to normal conditions. The next step is to jump the SCS line with the HDS, a term referring to the service check short line used in Honda Diagnostics. This helps access diagnostic functions within the system. Allow it to run for more than a minute to clear any temporary issues. Following this, disconnect the PCM connector B, 51P. This connector interfaces with the powertrain control module, which manages many transmission functions. With the connection removed, check for continuity between the designated test points. The first point is from the transmission fluid pressure switch, E, 6th clutch, 1P connector number 1, and the second point is PCM connector B, 51P. Number 28. Confirming continuity here is crucial. If it exists, the OP6SW wire is deemed functional, necessitating a PCM replacement if the issue persists. If there is no continuity, this indicates an open circuit in the wiring that should be repaired between the transmission fluid pressure switch, E, and the PCM. After completing the necessary repairs related to DTC P0990, it is crucial to verify the effectiveness of the repair. Begin by retesting vehicle operation to ensure that it is functioning as intended, particularly the shifting capabilities across all gears. During this process, observe whether the vehicle can now shift into all intended gears without restriction. It is also vital to check for the reappearance of the diagnostic trouble code. If the code does not return, this is a strong indicator that the repair was successful and the issue has been resolved. For final confirmation, clear the DTC again using the HDS and perform a test drive to monitor the vehicle's performance under various conditions. This complete verification process not only builds confidence in the repair, but also supports maintaining the integrity and reliability of the transmission system. Preventive maintenance plays a vital role in avoiding issues such as DTC P0990 in the Honda Pilot. Regularly checking the transmission fluid levels and quality is essential. Low or degraded fluid can adversely affect shifting and overall transmission function. It is also important to routinely inspect wiring and connectors associated with the transmission fluid pressure switch and other components to mitigate risks of corrosion, fraying, or loose connections that could lead to signal issues. Observing the transmission's performance during regular driving conditions can help catch any abnormalities early on, allowing for timely interventions before they escalate into serious faults. By adopting these preventive measures, owners can ensure a more reliable and smooth operating transmission system, minimizing the risk of future diagnostic trouble codes. In conclusion, understanding the implications of DTC P0990 is essential for maintaining the performance and reliability of the Honda Pilot's transmission system. The transmission fluid pressure switch E is a critical component that directs the functionality of the transmission and is key in ensuring smooth gear shifts. Systematic troubleshooting, as outlined, allows for precise identification and rectification of issues that may arise. By following the steps in a methodical manner, technicians can diagnose the fault effectively and implement necessary repairs. Additionally, being proactive with preventive maintenance measures can significantly enhance the longevity of the transmission system, reducing the chances of encountering similar issues in the future. Staying informed about these components, their functions, and potential failure points ensures a smooth driving experience for all Honda Pilot owners. Please like and subscribe to the channel. See you next time.